Okay, good afternoon, everybody. All right, so for today, we're going to move on to our new unit, but I'll go ahead and start off just by doing a quick warm up. So, back to just a little bit of conic section stuff. In this case, this one is a parabola. Okay, so write the equation of the parabola with a directrix at x equals 26 and a focus at negative 49. Okay. So these are really large numbers, obviously. So I'm not going to draw this to scale, but I'll at least sketch out, get a good idea of what I'm working with here. So focus at negative 49. Let's just let's assume we're kind of counting by 10 for each of those grid lines. So it would be about there. And then let's go ahead and say that x equals 26. So about here. All right, there's my directrix. So already just sketching this, I have a good idea about a couple things. All right, first of all being that I know that the parabola will always open up to be in the same side as or in the same direction as wherever the focus is. So in this case, since our directrix is on the right, our focus is on the left, then I know that my parabola is going to open to the left. All right, this should be a parabola that opens sideways to the left. All right, so the format of an equation like that is this. This is the standard form of a parabola that's opening either left or right. Okay, but we know it's opening left. So we first, let's say, figure out, well, we can determine the vertex, we can determine what that lowercase p is. They're kind of intertwined with one another. If you figure out one, you figure out the other. Let's first think about the distance between these two, right? At least the horizontal distance between the directrix and the focus. So if the directrix over here is at an x value of 26, and then the focus over here has a x value of negative 40, so the distance between those is 66. We also know that from the focus to the directrix, so that would be 2 times p, right? Because in the middle of those two things is the vertex. So that means our value for p should be, the distance should be 33. So dead in the middle here of 33. So this is the vertex. Right, so it's 33 this way and 33 this way. It's in the middle of the focus and the directrix. So I can go ahead and determine that the value, the point that that vertex will be at, is negative 7, positive 9, which is great because that tells me my h and my k. Now the other thing about lowercase p is, again, I'm remembering that this is opening to the left. So actually that should be negative 33. All right, we just kind of determine the negative after the fact. If it were opening to the right, then we would leave it as positive. But since it's supposed to open to the left, then we need to make it negative. So let's just go through and now plug in all of our values. Y minus k, so y minus 9 squared, equals 4 times negative 33 times x plus 7. And I'll go ahead and simplify that just a step more. 4 times negative 33, negative 132. Times x plus 7. So that must be the equation for the parabola that has a focus at the coordinate negative 40, 9, and a directrix at x equals positive 26. Okay. One thing I was going to mention. For conic sections, the PFA, let's see, let me try to bring it up here. Okay, on each of these for ellipses, you can see down here there's ellipse practice. For parabolas, the last resort is parabola practice. Hyperbolas, hyperbola practice. Okay, so on that, I didn't give you a lot of homework assignments here, but for the actual PFA, if you need practice, go into that each objective for the PFA and just open up that document, because that document for each of those objectives has like 20 questions on them, and it has the answers at the end that you can look at. Okay, so if you need practice, go into the playlist. There's a ton there for each type, for ellipses, for hyperbolas, for parabolas. So those are there. I didn't give you a lot of homework assignments, or any homework assignments, I think, this whole unit. So maybe like one or two. Love the colors. Thank you. Me too. I'm glad. Thank you for encouraging me to go through and change the colors. Change those defaults. Okay, so we're going to go on to talking about systems of equations. So a lot of that, at some points include things that you've already done before. Like today is stuff that you've sort of already done, but we'll make it harder. And then we'll go into some things that you've never seen before. Okay, but still is under the main idea of solving systems of equations. They look great from my roof. So the biggest difference right now is we're going to solve equations that have 3 variables in them. Okay, we're used to solving equations that just have 2 variables, right? Like 3x plus 2y equals 4, and negative 4y plus 7y equals 9, or something like that. Okay, where there's 2 distinct equations and 2 variables, but now we're going to do it with 3. 3 equations, 3 variables each. We're still using, so you might remember all the way back from Algebra 1, doing substitution and elimination. Okay, those are the 2 main methods we use for solving systems algebraically, and we're still doing that. It'll just be a little bit more difficult. So here's what we're going to do, is we're going to eliminate a variable in 2 of the equations. So we'll just pick 2 of the equations, any of the two, and say, let's get rid of the x's for these, or let's get rid of the y's or the z's, or whatever. All right, after we do that, we'll choose a different pair of equations and eliminate the same variable. So we'll pick a different 2, but we'll also still get rid of the x or the y or the z, whichever one we chose from before. And after we do that, now we should have a system that just has 2 equations, 2 variables, which is something that we're used to solving. Again, you've been solving those all the way back since Algebra 1. And you perfectly remember how to do it. Okay, so let's see what this actually looks like. So we'll start off with a basic example, all right, very short. So 3 equations, 1, 2, 3, and 3 variables, x, y, z. All right, a 3-variable system of 3 equations. This problem has already done some of the work for me. This second equation already does not have a z in it. It only has x and y. So we've sort of had fast-forwarded our first step. We don't need to eliminate a variable because we've already have an equation that eliminates one of the variables. So you'll see me do this a lot where I put like little stars next to an equation. This just tells me I'm going to come back and use this equation later. Right? It's really easy to lose track of what you're working with or what equations you have or what you're doing. So I would recommend doing some sort of highlighting or star or circle or something so that you know, hey, I need to use this equation later. Okay, so now as I look at the other 2 equations now, so I'll look at equations 1 and 3, that first equation and the third equation. I want to also eliminate z because the second equation got rid of z, or doesn't have z. So let's also get rid of z by doing something with the first and third equations. Okay, so I'm going to go to z and look at the coefficients. -2 and -1. So you might remember from elimination, we want those coefficients to be the same value, just opposite sign, one positive, one negative. So what I need to do is multiply one of the equations by something so that I'll have that, okay? Or maybe multiply both. But in this case, we only need to do one. I'm going to take this third equation and multiply the entire thing by -2. So don't forget, so you need to distribute that -2 to everything. So that would give me positive 8x minus 2y plus 2z equals -24. This first equation, I don't need to change anything. So I'll just copy it down exactly again. And we can see this is now done exactly what I want. Because for the z, my coefficients are -2 and +2. That's perfect. That's what we want. Same number, just different signs. So once we have that, we'll go through and add these 2 equations together. So we're just going to go kind of column by column following across and add stuff together. X plus 8x, that's 9x. -y plus -2y, it's -3y. -2z plus 2z, that's 0, so I don't need to write 0. You can if you want. -6 plus -24, -30. And again, I'm going to star this equation to let me know that this is important to me, that I'm going to use it later. or actually in the next step. Okay, so I'll take those two start equations. So 3x plus 2y equals negative 25. 9x minus 3y equals negative 30. And I'm just copying them down exactly, but just now I'm putting them together. So at this point, now I have these red equations is a system of two equations with two variables. Okay, so I want to go through the same process. I want to eliminate either the x or the y. It doesn't matter which one. Okay, you can choose. Sometimes there's an easier choice if we see that certain numbers will go together better, but ultimately it doesn't matter. As long as you do all your math correctly, like your calculations, then you should still end up at the same answer either ways. I'm going to choose to eliminate x, just because. So I'm looking at, that's bad. Okay, right now my coefficients for x are 3 and 9. So I want to make those the same coefficient, just a different sign. So I'm going to take this first equation, multiply it by negative 3. Yeah. So negative 9x minus 6y equals 75. And this second equation I'll just keep the same. 9x minus 3y equals negative 30. Add those two equations together. Negative 9x plus 9x is 0. Negative 6y plus negative 3y is negative 9y. 75 minus 30 is 45. Divide both sides by negative 5. So I get y equals negative 5. All right, that's one piece of my answer. We need to solve for all three variables. Solve for x, solve for y, solve for z. But that's fine. So let's just go back to one of those red equations, the ones that just have the x and y in them, and pick either one of them, and let's plug in y equals negative 5. So I'm just going to pick that first one. So 3x plus 2y, but y we know is negative 5, equals negative 25. Do some calculation. 3x minus 10 equals negative 25. Add 10 on both sides, so I'd get 3x equals negative 15. Divide both sides by 3. So I'll get that x also equals negative 5. Great. So now I have the value of x, I have the value of y, but I still need to figure out what is the value of z. So we'll go all the way back to one of our original equations. Right, one of those first three original that my problem had, and I'm going to plug in x and y to one of those equations. I'll pick that first one just because. X minus y minus 2z equals negative 6. Let's see if I can remember that. I already forgot. X minus y minus 2z equals 6, negative 6. Damn. Okay, so the first negative 5 comes from the x. The second negative 5 comes from the y. Just plugging into the first original equation. We could have also done the third. Okay, negative 5 minus negative 5. Okay, great. Those cancel each other out. Negative 2z equals negative 6. So I get z equals 3. Now, we actually want to write this all together as a final answer. So instead of a point like we're used to writing x, y, x comma y, this is also technically a point. It's a point in a three-dimensional graph. Okay, so not just the xy plane, but if we had x, y, z, a super fun 3D graph, then this is the point. So we'll just write x comma y comma z. Same thing, pretty much. This is also how you'll have to type it in on the PFA. Okay, whenever you're taking this PFA for systems, right, this is how it'll want your answer. And it's where you enter, you type the answer. So it's not multiple choice. So you will have to actually type parentheses, negative 5, comma, negative 5, comma, 3, parentheses. No spaces. Okay, when you type in your answer on the PFA, do not put spaces anywhere. Okay, never touch the space bar, just comma, negative 5, comma, negative 5, comma, 3, parentheses. So there's our first sort of, it still took a little bit of work, but that was still an easier problem because, like I said at the beginning, that second equation, the one that I highlighted in yellow, it already didn't have a z. So that took care of the first step for me. Usually I have to go through and get rid of a variable in two spots. Right, but this one already got rid of the z. So we just said, all right, well, let's just get rid of z again in some other equations, and we'll go from there. Okay. All right, let's check our next example. Sometimes it's also helpful to label these. It's early release. Class gets out at 12:40. Oh my god. You're right. The good news, well, if class got out 30 minutes ago, the good news is that Cassidy still won't be any more late than usual to our next class. So at least we have that going for us. Okay. Walk slow. For this system, we can start by eliminating any variable. Doesn't matter which one. What do you guys want to start with? What do we eliminate? X, Y, or Z? First response I get, that's the one I'm going with. X, got it. Okay. Now that's probably a good choice because if I look at all of my coefficients of x, 5, -1, and -1, pretty easy to work with. All right. So I am going to go through. Let's first do equation 2 and 3. So I'm going to take equation 3 and I'm going to multiply it by -1. So that would give me x plus 4y minus 5z equals positive 21. Whoa. Minus 5z equals positive 21. And that second equation, I'm just going to leave it alone. We'll add those together so that we have, oh wait, oops, a small error here. Negative x minus 5y plus 6z equals -24. And we'll just add column by column. So negative x plus x is 0. Negative 5y plus 4y is negative y. Positive 6z plus negative 5z is positive 1z. Negative 24 plus 21, negative 3. And again, at this point, I'm going to put some sort of indication that I want to use this equation later, but I'm going to kind of put it on hold for a moment because now I need to go back to my other equation and I need to eliminate x in two different ones. So we already did 2 and 3 and got rid of x. So now I can either choose 1 and 2 or 1 and 3. I'll go ahead and just choose 1 and 3, I guess. So equation 1, equation 3. So I'm just going to first copy those down. Now, since I'm trying to get rid of x, if equation 1 has a coefficient of 5 on x, then I want equation 3 to have a coefficient of negative 5x. Now, right now, the coefficient is -1. So I'm going to go ahead and multiply this by 5. All right, equation 3 times 5, so that would give me negative 5x minus 20y plus 25z equals negative 105. So I took equation 3, multiplied it by 5. Now we add those together. 5x plus negative 5x, 0. It's exactly what we wanted. Negative 4y minus 20y, negative 24y. 2z plus 25z, 27z. Negative 1 or 21 plus negative 105. Whoa. Uh-oh. All my chapstick fell off. Wait, nope, I still have one over here. Don't worry, we're safe. Luckily, I keep 12 tubes of chapstick around me at all times. What was I doing? Oh, negative 105 plus 21, negative 84. Yeah, negative 84. No, wait. Negative 105 plus 21. Are you an addict? Yeah, kind of. Little bit. Little bit. Is it bad? I don't think so. Chapstick rehab. I don't know. I've just always been in the habit of putting on a lot of chapstick. Otherwise, it's dangerous for me to go out in the sun, especially. You could be addicted to like 10 cookies. True. There are worse things. Okay, so here's my those two equations that I start. So now I'm going to put those together here. Now I have a system of these equations, and I want to eliminate y or z. So again, someone tell me y or z, which one? Both are pretty rough. Y, great. Coefficients currently are positive 27 and positive 1. So I'm going to take my first equation here and multiply by negative 27. Right, so that would give me 27y. Or wait, no, sorry. You said eliminate y, correct? Then never mind. We want 24. Right, because the coefficient for y is negative 24, so we'll multiply by negative 24. So that creates positive 24y minus 24z equals negative 24 times negative 3. So that would be positive 72. Right? 20 times 3, 60, 4 times 3, 12, 72. Yeah. So negative 84. And then we add our two equations together. So that'd be 0y plus 3z. And then 72 plus negative 84 would be negative 12. Solve for z. Z equals negative 4. And then we'll just work our way backwards to figure out everything else. So let's plug in that negative 4 to one of those red equations. Probably the first one would be easier. So negative y plus negative 4 equals negative 3. So that's just negative y minus 4 equals negative 3. So negative y equals 1. Multiply both sides by negative 1. Y equals negative 1. I know y. I know z. So let's work our way all the way back up to the top. One of our original equations we want to use to solve for x. It doesn't matter which one. I'll go ahead and use the second equation. I don't know. Why not? But I'll have to scroll up and down a lot. Negative x minus 5y plus 6z minus 5y plus 6z equals negative 21? Negative 24. Dang it. So negative x plus 5 minus 24 equals negative 24. Add 24 to both sides, so that would get rid of both of those. So I have negative x plus 5 equals 0. Add x to both sides. What? So x equals 5. And then to put that all together into one concise final answer, I'll write it x comma y comma z. So 5, negative 1, negative 4. If you're doing this on a PFA, don't put any spaces. My laptop overheated and his smart notebook crashed. Yeah, that definitely happens a lot. That's part of the reason why, like, whenever I'm writing sometimes and it like lags really bad, like not even just on streaming on Twitch, but like in class, whenever I'm trying to write something and it screws up, it takes a lot of work for these laptops to run smart notebook. It eats up a lot of RAM. But also that's what you get for tanning on your roof. Catching the rays. It's dangerous. I don't know what that means. Okay, and then lastly, really quick, we're not going to go through these unless you desperately want me to. But consider a situation that could happen. So in either one of these, the higher the UV index, the better you tan. Also, another way of saying that is the higher the UV index, the worse it is for your skin. But yeah, so I'm not going to work through all these hugely. But just something that could happen is in the midst of your solving, when you're doing your equations, so it's hard to say at what step it'll happen, but you could end up, after you're adding these equations together, you get something like 0 equals, 27. And, or whatever. I mean, it could be various things. You could get negative 12 equals 0 or whatever. Okay, the point is, on one side, you have a value that clearly does not equal the other side. Right? If this happens, okay, then we describe that system as inconsistent, and we would say no solution. So that's another thing that could happen. Sometimes it's on those questions on the PFA that if you're going through the solving and you all of a sudden end up at this equation, which makes no sense, like 0 equals 5 or 3 equals negative 12 or something that's just obviously not true, then that just means